Engineering applications of systems of linear equations, statics example. So an engineering student is trying to solve a statics problem, and his job is to determine two values of tension measured T1 and T2, and he's currently arrived to the following two linear equations. Negative 7.071 times T1 plus 8.66 T2 equals 0, and that 0.77 or 0.7071 T1 plus 0.500 T2 is equal to 95. And most likely where these come about is this is likely the sum of the force in the x direction. This is probably the sum of the force in the y direction of some hanging object that creates a force of 95 newtons there, and these are pulling it up. As we go forward and we talk about statics later, you'll see kind of how we get to these equations a lot of times. And so it's very good to be able to know how to solve these now. Alright, so our statics example, we've written it. We've got our equations all lined up so that our coefficients match up and our right-hand sides lined up. At first, they want us to solve it using addition. In general, we could use any one of the four methods on there that we've learned so far. Addition works really well this one because we have two coefficients that are exactly the opposite of each other. We don't even have to multiply to change things. So on this one, addition is a good choice. Because T1 is easy to eliminate. So let's just do that. So we want to add equation 1 and equation 2. And again, just for reference, I'm calling that one equation 1 and this one equation 2. So negative 0.7071. I'm going to write them again down here just to make sure we don't get lost up top. 0.7071 times T1. This is why it's important that your hands do what you're supposed to do, whether your mouth does or not. We add those two equations. Those two immediately cancel out. We didn't even have to multiply an equation to manipulate things. So we get 0 times T1 plus, add those together, we get 1.366 times T2. Add those together, we get 95. So T2, we can just do that division. 95 divided by 1.366. And I get that T2 is 69.55 newtons. And with that information, I can plug that into either equation. I'm going to choose to use equation 1 because there's less to deal with. So negative 0.7071 times T1 plus 0.866 times 69.55. An argument could be made to use equation 2 because I would get to multiply by 0.5, which would be a lot easier than multiplying by 0.866. But the calculator is pretty much going to have to do it anyway, so as long as I can type it in, we're okay there. So T1 is going to equal, I move that over the sign, it becomes negative 0.866 times 69.55 divided by negative 0.7071. And so for T1, I get my answer times negative 0.866 divided by negative 0.7071. And that's where I get 85.17 newtons for that. So T2 69.55, T1, 85.17. So addition was a good method for this one.